So in this session, we're going to cover two-factor authentication, what it is and why you want to use it for your PowerBuilder applications. So first, legal disclaimer, and let's go over the agenda. I thought I'd introduce myself briefly in case somebody out there doesn't know who I am. Then we're going to take a high-level overview of what two-factor authentication is. Then we're going to take a peek under the covers. What I mean by that is I'm going to describe how the two-factor authentication passwords are generated using for Google Authenticator. That's a specific form of two-factor authentication. And then deep in the weeds is when we actually go through the PowerBuilder code and see how I implemented the functionality to generate the Google Authenticator PIN values. And then we'll see a demo. So first, a little bit about myself. My name is Bruce Armstrong. I work for a company called Integrated Data Services. I joined them in 2004. Prior to that, I had been an independent contractor doing PowerBuilder development for 15 years. When I joined Integrated Data Services, they were a ISV using PowerBuilder to create client-server applications for customers. We've since migrated most of those applications over to HTML5 JavaScript with Java in the middle tier. However, we do have a few customers that still use the PowerBuilder version. In addition to PowerBuilder, I'm fluent in PL SQL, Oracle PL SQL, Java, C#, and I'm fairly comfortable with C++. Involved in a number of open source projects. One of them that's probably familiar to most PowerBuilder developers is the open source PFC libraries. Also, I created a utility using the PowerBuilder native interface, so that's in C++. It becomes a PowerBuilder extension that allows PowerBuilder apps to send email via SMTP. And then I created a plugin, actually a number of plugins, but specifically one for Jenkins that uses the autocompile utility available in PowerBuilder 2017 and 2019 to do automated compiles. So if you're looking to do continuous integration, and you might want to look at something like that to automate your PowerBuilder application compiles. A little bit about the company I work for. Okay, let's go into two-factor authentication. So two-factor authentication is a more secure way of requiring authentication to your application because it requires two things from the user, not just the username and password, but something else, something they have. So there's something you know and something you have, and there's actually a third form. It says something about you, where you can use a fingerprint like like phones do nowadays, or a retinal scan, or a face scan that some of the phones do nowadays. That's another way of doing two-factor. If they required that with a password, that would be two-factor authentication. But we're going to look specifically at how Google Authenticator does it. So in this case, you would have Google Authenticator on your phone, and you'd have your password, your username and password. And that the reason that makes that more secure is if somebody gets a hold of your password now, they still can't get into the app because they don't have your phone. Or if somebody gets a hold of your phone, they can't use the app because they don't know your password. They'd have to get both in order to get into the application as you. Okay, so let's take a high-level overview of how that works. So this is the sample application I've written, and I'll mention it probably several times throughout this, but the sample code is available from the Appeon website. So that you can strip it apart and use the pieces you want in your own applications. Also, I'll mention I did this session in Elevate 2019, but since then I've gotten some feedback from some of the people working with Power Server that it wasn't working for them, and they worked with Appeon support and determined what the issues were, and then I've put that back into the sample code. So now the latest version of the sample code does work correctly with Power Server as well. So if you're using that product, this should work for you too. Anyway, there's a couple pieces here. There's an application name, And then there's the user ID that the user's going to, this is going to be for all your users are going to use that same value. And this wouldn't be a user enterable value. I just did that for this demo. But you would have your users provide a user ID and a secret key. And from those three pieces of information, what we generate is a QR code. And what a QR code is just a way of digitizing a string value so that can easily be read by a QR code reader. What the QR code reader will do is turn that image there back into a string. And there's a specific string format that the Google Authenticator is looking for. So what you do is you scan this into Google Authenticator, and that registers the app with your user ID and your secret key within Google Authenticator. At that point, after that happens, Google Authenticator will start spitting out 6-digit PIN values, and it will change that 6-digit PIN every 30 seconds. And as we dig into the code here, that's by design. Anyway, you get what you would then do is when the user is going to log into your application, you would have them provide their username and password and the current 6-digit PIN being shown by Google Authenticator. And then in your application, you would determine what that PIN value should be compared to the PIN value the user entered. If it doesn't match, then it wasn't generated using Google Authenticator using that user ID and that secret code. And so you would deny access to the application. So this is an example of what Google Authenticator looks like, and with a 6-digit PIN value shown. And as I said, it's recalculated every 30 seconds. What happens when this app is running is as you're approaching the end of the 30 seconds, this number will turn red and start flashing, letting you know you're approaching the end of the 30-second interval, and then it will generate a new PIN value. So, okay, that's how that works. How has Google come up with those values, or how does any app that works with Google Authenticator come up with those values? Now, I'll apologize in advance. The way it does it is very convoluted, and don't blame me. It's blame the people who came up with temporary one-time passwords. But the fact it's so convoluted helps provide the security of the PIN value. So you're going to, this is what I was referring to earlier about, what you're going to be doing in the application now. You have the user provide the username and password, and the PIN, and the PIN generates the one-time password, temporary one-time password. I've got some references here. One is to a Wikipedia article that explains what these temporary one-time passwords are. There's an IETF standard. And one thing I'll note is that according to the standard, it doesn't have to be 6 digits. It can be it could be varying numbers of digits. And it doesn't have to be a 30-second increment. It could be a 60-second increment or some other increment. 30 seconds in an increment and a 6-digit PIN is what Google Authenticator does. So if you want to do two-factor authentication using temporary one-time password, but you're using some other service, you may need to determine how many digits they use, and what their period is for the values, and adjust the code accordingly. So the sample code I give you, I know works with Google Authenticator. If you're working with some other service, your mileage may vary. And there's an article from Free Code Camp here that explains an overview of one-time passwords and why you should use them. Okay, so now we're going to go under the covers. How does Google get these values? Well, it takes the secret code for the user, and then base 32 encodes it. Notice it's not base 64, base 32. It's the difference is when it gets encoded, base 64 uses 64 alphanumeric characters for the conversion. Base 32 only uses 32. And so if we took this really high secret code, 1 through 0 twice, and base 32 encoded it, this is what we'd end up with. Okay? We create an identifier that's the name of the app, and I just happen to call the app Google Authenticator Demo, and put it in a colon, and then put in the user ID. In this case, I used my email address. We insert them into this following string. So there's this sort of URL prefix. The identifier is this whole piece here. The app name, the colon, and the user ID. And then you suffix it with the question mark secret equals and then the base 32 encoded secret key. So in this case, this is the value I end up with. And what this string is, this is the string that Google Authenticator wants to get to register the app. So what we're going to do with that string is we URL encode it, and then we generate a QR code. And so that's where that QR code came from in that sample app. That's the QR code we generated for this string right here. Okay, so now it's time to validate the PIN. What we're going to do when we validate the PIN is do the same thing Google's doing to come up with that PIN value. One thing to note here, as we go in here, one of the key pieces of generating that 6-digit PIN, remember I said it regenerates every 30 seconds? It uses the current UTC time divided by 30 to generate an interval. What that means is that if the user's got Google Authenticator on their phone and you're trying to validate the code that it's producing in your app running on their computer, both of those have to have the actual current time. If they're off by 30 seconds, then you're likely to get different PIN values because they'll end up in different 30-second intervals, and as a result, generate different PIN values. Now, one of the things I suggest you might want to do, just to give the user a little leeway, is generate in your app the PIN value for the 30 seconds prior to the current value, the current values interval, and a future 30 seconds. So you get about a minute and a half there, and validate the PIN against all three of those, and that gives you a little room for error there. But if the user's phone is off by an hour or something like that, then you're never going to get a match. And the only thing you can do is try to encourage your users to make sure their phone is set to the correct time. So how do we generate that PIN value? Well, here's how we do it, and here's what I was referring to. We get the current time in UTC as a Unix epoch, which is the number of seconds since midnight, January 1st, 1970. And then we divide that by 30. So if today's time was May 1st, 2019 at 8 a.m., this is the number of seconds since midnight, January 1st, 1970. Divide that by 30, and that's our current interval. So we're at interval 51,889,920. We convert that to a 4-byte array, but it needs to be in what's called big Indian format. In the sample code, I use a Windows API function, but that Windows API function produces the byte array in Little Indian format. And so one of the things I do after I generate the value is I reverse the order of the digits, which is what the difference between big and Little Indian is. So if we convert this number right here to a 4-byte array, we get this value right here. And then we're going to invert that and put on 4 leading 0 bytes. So now we have this 8-byte array. We HMAC encode the byte array using SHA-1 and using the secret key for the user as the key for the SHA-1. And if this was the 8-bit array, this is the byte array we get out after we HMAC encode it using the user's secret key, assuming the secret key is the 1 through 10, 1 through 0, I guess, twice that I showed earlier. You take the last byte of that array and you do a bitwise and with F, which is hexadecimal 15. And in this case, when you do that, the result is 15. Okay, that determines the offset from which we copy 4 bytes from the encoded array. So I'm going to go back here. I'm counting on 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Except we're gonna go one more. I guess we're actually 0 indexed. So we're going to start with 199. And we're going to grab 4 bytes. So we're going to grab 199, 117, 230, and 20. We take the first byte of that 4-byte array and we do another bitwise AND with the hexadecimal value 7F. And the result of that is decimal value 71. Sorry for the mix of decimal and hexadecimal. So now what we have, if you're taking notes, is 71, 117, 230, 20. Okay. Now we take and we multiply each of the bytes by the following. What we're doing is shifting bits left. So we take the first bit, that was 71, and multiply it by 2, that should be to the power of 24. And it gives us this number. The second bit, we multiply by 2 to the 16th. Yeah, I got it correct that time. Third bit by 2 to the 8th. And the last bit we just take by itself. And we add all those together. And we get 1,198,908,000, whatever. So now we have this number here. We take and we do a mod of that with 1 million. And what we end up with in this case is 908,948. Okay? If it's less than 6 characters long, we pad it with zeros on the left. And so in this case, we didn't have to do that. And the resulting pin is 908,948. Okay, that is, like I said, don't blame me, blame the people who came up with temporary one-time passwords. That's how you generate a temporary one-time password. How we do that in PowerBuilder, that's what we're going to look at now. So this is how we generate the QR code. So we have this coder object that was introduced in 2000. I know it got, well, okay, it was introduced maybe in 2019, but in R2 is when they added base 32 encoding. So we're going to use that coder object. We're going to take the key value that the user entered. We're going to convert it to a blob in UTF-8 because that's what the base 32 encode function is looking for. And we're going to get a string back that is the base 32 encoded value. We're going to plug that into the back half of that URL we're putting together. The identifier, I don't show it being put together here, but the identifier, remember, is the name of the application, a colon, and then the user's ID, in this case, the email address. So we put that whole string together. We need to URL encode that, and once again, the coder object comes to our rescue. It has a URL encode function. So we convert it once again to a UTF-8 blob because that's what the URL encode function is looking for. And we get back the URL encoded version of that string. We are then going to use, in this case, I'm using a Google REST web service to generate the QR code. So I'm using the HTTP client to take, and the way you do this with Google is you take this string here, which says I want to create a chart. The chart type I want to create is QR code. These are the size. This is the size I want, and this is the string I want to convert into a QR code. And it's that long string that Google Authenticator wants. So I send the request to Google. I get the response body back, which is a blob, which is the QR code bitmap, and I just assign it to the picture control on the window. That allows the user then to register the app with Google Authenticator. They start getting PIN values. They enter the PIN value in the application. Now I need to generate that. I need to see what the current PIN value should be. So the way I do that is I get the current Unix epoch, and I've created a function that does that for me. And I divide that by 30, which is the interval that Google Authenticator uses. That gives me a current interval. And then I have a function I've created which generates the PIN value based on the key value and the current interval. To get the current Unix epoch, I use a couple Windows API functions. One of these gets the current time zone for the computer. The other one converts whatever time you've got to UTC. But you need to tell it what the current time zone is, which is why I'm using the current time zone there. So I say, tell me what the current time zone is. I get the local, I get the current time as far as the computer knows in the local time zone, and I assign it to this system time structure. And then I do the conversion. So I'm passing in the local time in the local time zone. I'm passing in the local, I'm telling it this is my local time zone. And then I get back the system time in UTC. Then what I do then is I convert that back into a date time using the date time and date time functions. And so now I've got a current date time in UTC. And now I'm going to do a days after, because remember I want the Unix epoch, which is the number of seconds since January 1st, 1970. So I do the days after and seconds after, convert the days into seconds, add it to the number of seconds, and that gives me the Unix epoch. Okay. Now this is that was explaining how I got the Unix epoch to get the counter, which is the current interval. What I need to do now is convert. Remember when I was going through and explaining how we can generate the pin? We say we take that counter and convert it to bytes. That's what I'm doing here. I'm using the longtobytearray function, and I'll show you that in a bit. But I'm going to convert that counter into bytes, and then I'm going to do a blob on it. Now, in earlier versions of this code, I was using a blob function in the PowerScript blob function. For some reason, that works when it's working with bytes. It apparently works a little bit differently in Power Server than it does in PowerBuilder, and so we have a function now that does the conversion for us that works in both PowerBuilder and Power Server, and that's shown a little bit later. That converts it into a blob. I'm going to take the key value and convert it into a blob. Okay. Now I'm going to take the cryptor object. This is what I'm going to do the HMAC SHA with. So I'm doing the HMAC encryption using SHA-1. I'm passing in the blob representing the counter, and the blob representing the user's key value. That gives me a hashed counter value. Oop, too far, too fast. Go back. I'm going to turn that into a byte array, and then we get the last byte. We need to do a bitwiseand with it with F, which is 15 in decimal. So that gives me my offset. Okay, then I loop through. I get the offset plus my index value here. That's and so I'm looping through those 4 bytes. And then remember I do the bitwiseand on that first byte with 7F, which is 127, and multiplying that by 2 to the 24th. Take the next byte, multiply by 2 to the 16th, next byte 2 to the 8th, and just take the last value by itself, add those all together, do a mod with 1 million, and that gives me my my pin value. I'm checking to see if the pin value is less than 6 characters, and if it is, I fill in on the left with zeros to make it 6 characters. That's the pin value. Okay. Here's the long to byte array function. I'm not going to go into it in terrible detail. Like I said, the code is available on the Appeon website. You can download it and go over it in great detail on your own. This is another place where I was using a long to bytes function. That it's actually in PowerScript. We got some different behavior between PowerScript and PowerServer there. So we create, Appeon support actually put the function together, and I just included it back into the sample here so that it works with both PowerBuilder and PowerServer. But and it's shown later here in another slide. There's another function that does the copy long to bytes, then padding it with 4 zeros. And remember the API function gave us little Indian, and we wanted big Indian, so we copy the bytes over in inverse order. This is just a bitwiseand that is used in a couple different locations there. This was borrowed from PFC. Here's the OF blob function. This was put together by Appeon support because the blob function in PowerScript that operates on bytes works a little bit differently between PowerBuilder and PowerServer. And then this is the copy long to bytes, once again put together by Appeon support, because the long to bytes function in PowerScript works a little bit differently between PowerScript and PowerBuilder and PowerServer. So that's enough digging through PowerBuilder code. Let's actually see how this works. Okay, so I'm going to run the application, sample application now. Once again, the Google Authenticator demo is the name of the app. My email address is what I'm using for my ID. I've got the super secret password there, that secret key. When you grab this off the Appeon website, of course, these are all editable fields. You can change them to whatever you want. But we go ahead and generate a QR code from that. Okay, and then this is my iPad over here. Oop, trying to get these both on the screen at the same time. And I want to cover up the QR code because I got to read that. Okay, so you see Google Authenticator down there in the lower right. I'm going to click on that. I've already got an account on there because Nintendo uses this for their two-factor authentication. And you saw the flashing red there when we go into another interval. I'm going to hit the plus sign up there at the top to enter a new account. It'll say scan barcode. Okay, and I'm going to point it at the screen there. And see, it grabbed it and generated another 6-digit number. So that's the the temporary one-time password for this current interval. And I'm going to hit validate right here. And what we should see is that we got this. Whoa, we did not get the same value. There we did. Okay, so yeah, we got the same value now. So apparently, I may have a few seconds off here, or maybe it generated a new value while I was over here trying to get everything back on the same screen. But there you go. So it's flashing now. It's going to give me a new value. If I hit value date over here, yeah, there's that new value. So apparently we're in sync. Apparently it generated another value when I wasn't watching. Anyway, that's how the authenticator works. So you have your user enter their username, password. They enter that 6-digit code they got here. You run the code that then generates the value you think you should be getting. Compare the two. If you get the same value, you're a lot more reasonably certain that this was the user than you were with just the password. There you go. There's the next code value again. Okay, so that's how that works. Go back to the samples, the slides here. just to indicate, community.appeon.com is, many people know this because of the Q&A section, but there's tech articles. I've got some blog articles up there, and there's code exchange, and that's where the copy of this sample code is at. So I invite you to go ahead and download that and look it over and use whatever you want in your own applications. With that, thanks for your attention. I hope you enjoy the rest of Elevate 2020.